Continuation of Model 3. Till now we have studied formation of PDE. We have formed the PDE. Now we'll study how to find the solution of the PDE. Okay. We have solved so many quadratic equations, cubic equations, and in numerical methods also many solutions we found. So here also we are finding solution of PDE. Solutions of PDE is nothing but we consider one PDE that may be homogeneous or non-homogeneous, and we solve it to get the solution of that equation. So what is solution of PDE? A solution, or it is also called as integral of a PDE, is a relation between the dependent and independent variables satisfying the equation. Suppose if you take one quadratic equation, very simple example I am taking. If you found the roots of that equation, if you substitute those roots in that equation should be satisfied. Similarly here, solution of PDE, here that is the relation between dependent and independent variable which satisfies the given PDE. It is called solution of PDE. The same PDE may be having one or more solutions, but ordinary differential equation has unique solution. So here in this module we are going to solve the PDE in the form they are of first order and of first degree. In the form, general form is given here, f of x, y, z, p, q is equal to 0. X, y, z are, x and y are independent variables, z is dependent variable, p, q. P is dou z by dou x, that is first order, first degree differential term. Q is dou z by dou y, it is also first order, first degree differential term is equal to 0. So it is a general form of PDE which we are going to find out solution for that. So solution of non-homogeneous PDE by direct integration. Now we are going to study the solutions of non-homogeneous PDE. You know what is non-homogeneous PDE? We have discussed in the first class itself. Now we are finding the solution for that by direct integration, that is integration. We all know if one differential term is there, if you integrate that, we'll get the solution of that equation. It is just very simple, means d by dx of x is there. If you integrate it, you will get the value of x is equal to. So similarly here, solution of non-homogeneous PDE by direct integration. In this method, we find the dependent variable which being the solution by removing the differential operators through the process of integration. So here through the process of integration, that is important. What is the working procedure? How we'll find out these? Some steps I have written here. First step, always consider the given partial differential equation, given equation. Always it will be in the form, here we are studying non-homogeneous, here it will be in the form dou u by dou x is equal to x square. U is function of x and y. U is called as a dependent variable. So here finding the solution of this PDE is nothing but our answer should be u is equal to some function of x and y. That is the solution. First step is take the given equation, given PDE. Second step is, see here, dou u by dou x is equal to x square. It is partial differentiation of u with respect to x. To find out u, we have to integrate this with respect to x. So integration of dou u by dou x with respect to x is u. Okay, is equal to integration x square dx plus integrating constant k. Here always remember, here we are integrating with respect to x, then y term is constant. Here we have to take k is a integrating constant, so k should be always function of y. Why? Because always term containing y is constant here while differentiating with respect to x. So k is f of y. U is equal to x cube by 3 plus f of y, which is the required solution of the given PDE, that is dou u by dou x is equal to x square. In this note, suppose you are integrating with respect to x, you have to take integrating constant as a function of y. If you are integrating with respect to y, you have to take integrating constant as a function of x. That is very important. So one example, simple example I am considering. First example, solve dou square u by dou x square is equal to x plus y. It is non-homogeneous differential partial differential equation. Here, by seeing the given PDE, you have to check there itself what to find out, how to find out. So here u is differentiated 2 times with respect to x. So we have to integrate the given PDE 2 times with respect to x to get u is equal to. That time only you have to decide that. So what is the first step? First step is consider the given PDE. So I have written here the given PDE dou square u by dou x square is equal to x plus y. That is the first step. Next step, we have to split the given differential term. As I have told, u is differentiated 2 times with respect to x. So it can be splitted like dou by dou x into dou u by dou x. This is nothing but dou square u by dou x square is equal to x plus y. Okay. Next, dou by dou x, first term should be eliminated. For that one, we have to integrate with respect to x. So integration of dou by dou x, dou u by dou x with respect to x is dou u by dou x. Here we are integrating with respect to x. So y is kept constant. So integrating constant should be f of y. Therefore, integration x plus y dx plus f of y, that is integrating constant. Next, integration of x with respect to x is x square by 2. Integration of y with respect to x is x into y plus f of y. It is one step. Next step is dou u by dou x is there. We want u is equal to. So here again integrate with respect to x keeping y constant. So integration of dou u by dou x with respect to x is u is equal to integration x square by 2 plus xy plus f of y dx. Here we are integrating with respect to x, then constant should be a function of y. Already above we have taken f of y, so here we will take g of y. U is equal to integration of x square by 2 with respect to x is x cube by 6 plus x integration of x is x square by 2 y plus integration of f of y. F of y is constant. So integration dx is x f of y plus g of y, which is the required solution. Let us consider next example, that is solve dou cube z by dou x square dou y is equal to cos 2x plus 3y. It is non-homogeneous differential equation, partial differential equation. There only you have to check. Here z is differentiated 2 times with respect to x and 1 time with respect to y. There only you decide that we have to integrate 2 times with respect to x, 1 time with respect to y. And we have to introduce the arbitrary functions, that is arbitrary constants or integrating constants as first two, that is with respect to x, means we will introduce f of y, g of y. With respect to y is there, then we introduce h of x. These things we have to decide first only. Then solution, consider the given PDE, then we have to split the LHS part dou cube z by dou x square dou y. Dou by dou x, right? Dou by dou x, then dou z by dou y. It will be dou cube z by dou x square dou y. Check again whether it is correct or not. So after checking it is correct, is equal to cos 2x plus 3y. Right? Now one by one we have to eliminate by integrating. First term, we'll eliminate dou by dou x, that is integrate with respect to x keeping y constant. So integrating with respect to x, dou by dou x first term will be eliminated. We get dou by dou x dou z by dou y is equal to integration cos 2x plus 3y dx plus integrating constant which should be function of y plus f of y is equal to, what is integration of cos x? It is sin x. Here integration of cos 2x plus 3y is sin 2x plus 3y divided by differentiation of 2x plus 3y, that is 2 divided by 2 plus f of y. Okay, again here we have got dou by dou x dou z by dou y. Dou by dou x should be eliminated. For that one we have to integrate with respect to x keeping y constant. So integrating we get dou z by dou y is equal to integration sin 2x plus 3y whole divided by 2 dx plus integration f of y dx plus integrating constant which should be a function of y g of y. Okay, then dou z by dou y is equal to integration of sin x is minus cos x. So integration of sin 2x plus 3y is minus cos 2x plus 3y, again divided by differentiation of 2x plus 3y with respect to x, it is 2 plus integration f of y dx. F of y is constant, so integration of dx is x into f of y plus g of y. Again second step is over. Next integrating with respect to y. Here because dou z by dou y is there, to get z we have to integrate with respect to y. So the integration of dou z by dou y with respect to y is z is equal to minus 1 by 4 integration of cos x is again sin x sin 2x plus 3y differentiation of 2x plus 3y with respect to y is divided by 3 plus integration x integration f of y dy plus integration g of y dy plus integrating constant, it is h of x. Why it is function of x? Because here we are integrating with respect to y. Then I'll take, I don't know what is f of y or what is g of y. So I'll take for integration f of y dy as capital F of y, and for integration g of y dy I'll take capital G of y. Then the solution is written as z is equal to minus 1 by 12 sin 2x plus 3y plus x capital F of y plus g of y plus h of x, which is the required solution, where f of y is equal to integration f of y dy and g of y is equal to integration g of y dy. Next is problem number 3. It is a very important problem. It appeared in June 2015, 17, 18, December 16. In this problem, we will discuss how marks will be distributed also. First, read the problem and try to understand it clearly. First, what is given? Solve dou square z by dou x dou y is equal to sin x sin y, for which dou z by dou y is equal to minus 2 sin y when x equal to 0 and z is equal to 0 if y is an odd multiple of pi by 2. First try to understand the given problem. First line, that is solve dou square z by dou x dou y is equal to sin x sin y. Already we know how to solve this such examples. Here z is differentiated 2 times with respect to x and y. One time z with respect to x and another time with respect to y. Okay, that is first thing. First we'll find out the solution. Then we'll check the given conditions, how to apply those conditions. First consider given PDE. Dou square z by dou x dou y is equal to sin x into sin y. Or we can split it as dou by dou x dou z by dou y is equal to sin x into sin y. Right? By seeing this, we will get to know that it should be integrated with respect to x, integrated with respect to y. So, when we integrate with respect to x, there we should introduce f of y, with respect to y, g of x. These are the things you should think before only. Next, first we have to eliminate dou by dou x. For that one, integrate with respect to x, treating y as constant. What we will get? Dou z by dou y is equal to integration. Sin y is constant because we are integrating with respect to x. Integration sin x dx plus integrating constant f of y. Dou z by dou y is equal to sin y. What is integration of sin x? It is minus cos x. Minus sin y into cos x plus f of y. It is first equation number 1. Always write down the answers in block. Then again we have to integrate. First we will find out the solution. Again we have to integrate with respect to y because dou z by dou y is there. Integrate with respect to y, we get z is equal to minus cos x is constant, integration sin y dy plus integration f of y dy plus integrating constant, it should be function of x because we are integrating with respect to y, plus g of x. Z is equal to minus cos x. What is integration of sin y? It is minus cos y plus f of y, that is integration f of y dy. I have taken it as capital F of y plus g of x, where f of y is equal to integration f of y dy. So finally z is equal to cos x cos y plus f of y plus g of x is equation 2. Here question will be for 7 or 8 marks. First, up to first equation 1 you will get 2 marks, up to equation 2 you will get 3 marks, total 5 marks here, and rest all for putting initial values and all you will get 3 marks, or else sometimes if it is for 7 marks, for equation 1 2 marks, equation 2 2 marks, and remaining for 4 marks or 3 marks. So this is one step, that is we found the solution. Now we will think about the given conditions. What are the conditions given here? We have given two conditions. One is dou z by dou y is equal to minus 2 sin y when x equal to 0. First we will apply this condition in equation 1. So putting these conditions in equation 1, what we have to substitute? In place of dou z by dou y, substitute minus 2 sin y and x is equal to 0. So consider equation 1, substitute there. Dou z by dou y is minus 2 sin y, minus sin y, cos x is 0, cos 0 plus f of y. Cos 0 is 1. So minus 2 sin y is equal to minus sin y plus f of y, or f of y is equal to minus sin y. We found the value of f of y. Again we have to find out capital F of y. Capital F of y is nothing but integration f of y dy. Here integration f of y is just now only we have got minus sin y dy. What is integration of sin y? It is minus cos y, minus minus it is plus. So we get f of y is equal to cos y. Substitute this in equation 2. Equation 2 becomes z is equal to cos x into cos y plus cos y, because f of y is cos y, plus g of x. Let it be equation 3. Now we will use another condition given. What is that condition? Z is equal to 0 if y is an odd multiple of pi by 2. Odd multiple means odd number is always represented as a 2n plus 1. Remember this, always odd number is 2n plus 1. So here it is given that y is equal to 2n plus 1 pi by 2, odd multiple of pi by 2. Sometimes they may give z is equal to 0 if y is equal to 2n plus 1 pi by 2, or they may give y is an odd multiple of pi by 2. Always remember that. So we will substitute this z is equal to 0 and y is equal to 2n plus 1 pi by 2 in equation 3. We get z is equal to 0, it is given cos x into cos y is 2n plus 1 pi by 2 plus cos 2n plus 1 pi by 2 plus g of x. So what is cos 2n plus 1 pi by 2? It is always 0. Substituting cos 2n plus 1 pi by 2 is equal to 0, we get g of x is equal to 0. Substitute this in equation 3. We get z is equal to cos x cos y plus cos y, g of x is 0. So z is equal to, final answer is cos y into cos x plus 1. Here you will get 3 marks. Always remember, when conditions are given, then in the final answer there should not be any function of x or function of y. You have to find the values of f of y, g of x or f of x, whatever it may be. You have to find the value of that by using the given conditions. This is very important example. You have to practice it, as it is a very lengthy problem, but problem is very interesting. Step by step you practice this example because it is very important. Next, homework problems. 2 problems are given. One is dou square z by dou x dou y is equal to x by y plus a. Just check here, z is differentiated one time with respect to x, one time with respect to y. So first you have to integrate with respect to x, then with respect to y, and integrating constants, first time f of y, second time g of x, right? It is a direct problem. Second problem, that is solve dou cube z by dou x square dou y plus 18xy square plus sine 2x minus y is equal to 0. Just you can write down dou cube z by dou x square dou y is equal to, shift all those to RHS. Then here z is differentiated 2 times with respect to x, 1 time with respect to y. Split it, then integrate 2 times with respect to x, 1 time with respect to y, and integrating constants f of y, g of y, h of x. Then find the solution. And always don't keep the homework problems pending. Solve the problems. If you are not getting, then just send me the problem, I will solve and send. But you have to try it. 4. This is also very important problem. It appeared in June 2016 and December 2017. First, solve dou square z by dou x square is equal to xy subject to the conditions that dou z by dou x is equal to log 1 plus y when x equal to 1 and z is equal to 0 when x equal to 0. Again here 2 conditions are given. First, don't bother about the conditions. First, always concentrate on finding the solution. Then step by step we will substitute the given conditions. There are 2 conditions, we will substitute 2 conditions to get the value of the functions of x or y as the case may be. First, consider the given PDE. It is dou square z by dou x square is equal to xy. Okay, here z is differentiated partially with respect to x 2 times. So we have to judge there only, that is z is differentiated 2 times, mean 2 times with respect to x means we have to integrate with respect to x 2 times. So integrating constants will be f of y and g of y. It is half done. Next, first split up dou square z by dou x square as dou by dou x, dou z by dou x is equal to xy. First integrate with respect to x, treating y as constant. Dou z by dou x is equal to y is constant, y integration x dx plus integrating constant f of y. Dou z by dou x is equal to y as it is, integration of x is x square by 2 plus f of y. Let it be equation 1. One part is over. Here you will get 2 marks. Next, dou z by dou x is there. So integrate with respect to x. Integrating with respect to x, treating y as constant. Z is equal to y is constant, y by 2, integration x square dx plus integration f of y dx plus integrating constant, it should be function of y plus g of y. Z is equal to y by 2, integration of x square is x cube by 3 plus integration of f of y, it is constant, f of y as it is, integration of dx is x f of y plus g of y. Finally, z is equal to x cube y by 6 plus x f of y plus g of y. Let it be equation 2. Here you will get 2 marks. Total 4 marks. So now we found the solution of a given PDE. Next we will check the given conditions. What is the first condition? First condition is dou z by dou x is equal to log 1 plus y when x is equal to 1. Substitute this condition in equation 2. So dou z by dou x is equal to, in equation 1 we have to substitute. Dou z by dou x is equal to log 1 plus y and x is equal to 1. First, dou z by dou x, it is log 1 plus y by 2 because x is equal to 1 plus f of y. So f of y is equal to log 1 plus y minus y by 2. Substitute this in equation 2. In place of f of y, you have to substitute this. Z is equal to x cube y by 6 plus x. In place of f of y, substitute log 1 plus y minus y by 2 plus g of y. Let it be equation 3. We have other condition, that is z is equal to 0 when x equal to 0. Means put z is equal to 0 and x is equal to 0 in equation 3. Z is in equation 3. Using this in equation 3, we get, that is equation 3, z is equal to 0 and x is also 0. So first two terms will be eliminated and we will get g of y is equal to 0. So substitute this in equation 2. Z is equal to x cube y by 6 plus x into log 1 plus y minus y by 2, which is the required solution. Next, problem number 5. Here it appeared in June 2016. Solve dou square z by dou x dou y is equal to x by y subject to the conditions dou z by dou x is equal to log x to the base e when y is equal to 1 and z is equal to 0 when x equal to 1. Again here two conditions are given, and only difference between this problem and previous problems is what is given here, dou z by dou x is given, and in the problem dou square z by dou x dou y. If you split it, what you will get? Dou by dou x, dou z by dou y you will get. But here dou z by dou x is given. For that one, and we know that dou square z by dou x dou y is same as dou square z by dou y dou x. So just I'll take given equation as dou square z by dou y dou x is equal to x by y. That can be taken. So dou square z by dou y dou x can be written as dou by dou y dou z by dou x is equal to x by y. Remember this. Just you have to check the conditions. In the condition dou z by dou x is given, so somewhere we have to substitute that. Here for that sake we have taken here dou z by dou x. Integrating with respect to y, treating x as constant. So dou z by dou x is equal to integration, x is constant, x integration 1 by y dy. We are integrating with respect to y, so integrating constant should be function of x plus f of x. So dou z by dou x is equal to x integration of 1 by y is log y plus f of x. Let it be equation 1. We want z. For that one we will integrate with respect to x, treating y as constant. So integration of dou z by dou x is z is equal to log y, it is constant, integration x dx plus integration f of x dx plus integrating constant. We are integrating with respect to x, so integrating constant should be a function of y, g of y. So z is equal to y as it is, integration of x is x square by 2 plus integration of f of x dx, will take it as capital F of x plus g of y. Let it be equation 2, which is the solution of the given PDE. Now we will check the conditions. What is the first condition? Dou z by dou x is equal to log x to the base e when y is equal to 1. So in equation 1, we will substitute dou z by dou x is equal to log x to the base e and y is equal to 1. What we will get here? Dou z by dou x is log x is equal to x into log 1 plus f of x. Log 1 is equal to 0. So log x is equal to 0 plus f of x. F of x is equal to log x. Again here we have taken integration f of x dx, that is nothing but capital F of x. So that we have to find out. F of x is equal to integration f of x is log x dx. And how will you integrate this? It is a standard problem in PU, you have studied this. Always integration of log x, we use integrating by parts. Log x as a first function and 1 as the second function. Integrating by parts, f of x is equal to first differentiation of integration of first function into differentiation of second, that by using integrating by parts you will get x log x minus x, that is a standard formula. Integration of log x is x log x minus x. So substitute this in equation 2, we get z is equal to x square by 2 log y plus x log x minus x plus g of y. Let it be equation 3, and one more condition is given there, that is z is equal to 0 when x is equal to 1. So in equation 3 we will substitute z is equal to 0 and x is equal to 1. We get 0 is equal to 1 by 2, x is 1, so log y plus again x log 1 is 0 minus 1 plus g of y. So g of y is equal to 1 minus 1 by 2 log y, or minus 1 by 2 log y is nothing but log root y. Substitute this in equation 3. Z is equal to, we get x square by 2 plus log y plus x log x minus x, and g of y is 1 minus log root y, which is the required solution.